In software engineering, we are taking chapter number 34, project scheduling. Defining a task set for the software project. Now, for any work to schedule, those work have to be compartmentalized, being given time, and properly arranged so that they can be tracked and controlled. So an effective software process should define a collection of task sets. Task sets means a set containing various tasks, and each designed to meet the needs of different types of projects, because the projects can be of different type. A task set is what? If I make a collection of some certain task, that is called a task set. And this will consist of what? It will consist of the software engineering work task. That is, a task set will contain the task, different tasks, work to be done, and milestones. That is, when it will start, when it will end, what time, duration, etc. And what will be the output? That is the work product after doing this task. And finally, the quality assurance strategy, like a filter. So in a project schedule, a task set must be distributed on the whole project timeline from start to finish. So the task set, as I said, it will vary. Task set for different projects will be different. So the task set will vary depending upon the kind of project, the type of project. So what can be the different type of project which we are talking about? First one is the concept development projects. Now, as we are going to take the example of this, so you need to know that this is initiated to explore new business concept or application of new technology. Say new technology has come, new concept has come, a business concept. Now this concept development projects work for that. The second type is new application development projects. Now customer is coming to you. He says, I want an e-commerce website. That is a new application development projects, because this is a specific customer request. The another type is application enhancement projects. Now there are certain softwares projects which are already there, and they may go certain major modification in terms of function, in terms of performance, in terms of different interfaces to be opened and connected. So for example, the UDP can be changed to TCP/IP, like this. Application maintenance projects, it starts when then we need to correct, adapt, or extend the already existing software. So correction, adaptation, and extension, this comes under the maintenance projects. Okay. Now this is the fourth one. Finally, the re-engineering projects. Re-engineering projects, that is, there is already a software which is being used that is called a legacy software, 1960s, 1970s, like that. Now if you want to rebuild this system as a part or as a whole, means completely, or some part has to be rebuilt. So any project type you choose, many factors that affect, that guide or influence the task set to be chosen. Because ultimately the project scheduling is all about choosing the right task and then doing the timeline activities, that is tracking, control, and progress. So first thing is the size of the project. Small, complex, moderate. Number of potential users of this software or the project. What is the mission criticality? Is it a technology development, or it has to be completed on time? What is the time duration for which it is going to be used? Application longevity. And whether the requirements are clear to us. Stability of the requirement. Whether you are very clear about what the user want. Then the ease of customer or stakeholder developer communication. That is, if you can communicate with the party, then you can easily make the software because you are quite sure about the requirements. Then the maturity of applicable technology. Whichever technology you are going to use or develop, is this mature or not? And then the performance constraint. For example, maturity I was talking about 6G. It has not come, so you cannot do anything for that until it is matured. For example, a file transfer is there, a performance constraints I'm talking about, 1 GB in 1 second. Is it possible? Can you do it? And whether this software will be as a desktop software or it will be inside your washing machine or your microwave, that is the embedded, non-embedded. Project staff, how many people? 2, 20, 200. This also influences the task set. The re-engineering factors. How much needs to be changed? How much needs to be adapted? How much needs to be extended? A task set example. So let us take the project. There are different 5 types of projects. So concept development projects. As we know, they are initiated to explore the new business concept or application of new technology. So this concept development projects, let us see how we can make the task set. So these concept development projects, they are approached by certain major tasks, defining them. That is how to find out the major task first. Major task means the word. That is, they have a prescribed visible output. First one is concept scoping. Concept scoping, because in concept development projects, the first thing comes is the development of scope. So this determines overall scope of the project, what you want to do, what is your underlying idea, and what are the constraints. Then we have to do the preliminary concept planning. And this planning establishes organization ability to undertake work implied by what? By the project scope. What concept scoping you have done, then what is your ability, what work you are going to do with respect to this scope. And technology risk assessment. As this is a new technology work, concept development projects, here we evaluate the risk, the problems associated with the technology to be implemented. Proof of concept. This demonstrates the viability of a new technology. It's all about new technology and new concept which we are trying to achieve. Then the concept implementation. This concept implementation implements the concept representation in a manner that can be reviewed by whom? Customer. And is used for marketing purposes when it is to be sold, when a concept must be sold to other customers or management. Then we'll do the customer reaction. That is to solicit the feedback on a new technology concept and also to our target specific customer applications. This is the major task we are talking about. Now when we have devised and found out the major task, next part is to refine the major task to get the actual task which has to be put on the timeline as an activity or as a task. So the macroscopic schedule, that is the bigger schedule, must be refined for a major task to create a detailed project schedule. That is, from macroscopic you have to go to microscopic. So this refinement is decomposing these major tasks which we have already defined into a set of subtasks that can be put in a task set. Okay, this different tasks, how they are related, their concurrent, parallel, sequence, which way. But before that we have to decide what are the subtasks. Let us take the first major task of the concept development project which we just saw. It is concept scoping. So the major task is concept scoping. Now let us see how are we going to do the task decomposition in this case. First we'll start with the concept scoping. This is the first task, task 1.1. And you please remember 1.1, 1.111, all these are the subtasking. The first one will be to identify the needs and benefits and potential customers. The second part, we have to define the desired output and control and input events that drive the application. Now we have to begin the task 1.1.2. We are trying to now make the subtasking or this task set are created for 1.1.2. So we begin this task and now it becomes 1.1.2.1. We started with 1.1. Then we came to 1.1.1. Then we came when 1.1.2. Then we went to 1.1.2.1. These numbers I'm just saying that this is how we are decomposing it into different tasks which will be actual activity of the task of the functions. So first we have to do the review, written description of the need. Then we have to derive the list of customer visible outputs, inputs. Then we have to do again the technical review, reviewing the output input with customers and talking to them and revising if it is required. Then this work is done. This task is been defined now. So these are the subtasks we have made. Then we define the functionality behavior of each major function. Okay, this is what have to be done. Then we begin this task 1.1.3. These are the subtasks for 1.1.3. So 1.1.3.1 will be the technical review. So what we have got in 1.1.2, we have to review the output and input data objects derived in that task. Then we have to derive a model of functions and the behaviors, because we are talking about functionality and behavior here. Then again we have to do the technical review, reviewing the functions and behavior with customers, talking to them and getting the feedback and revising them. Then the 1.1.3 is finished. Okay. Now we have to isolate those elements of the technology that has to be implemented in the software. Then research availability. If there is existing software, there is already a software present, then this will be 1.1.5. Then we have to define the technical feasibility. Okay, whether it is feasible or not. For that we have to do all the technical stuff for that. And finally, making a quick estimate of the size. If we are all aware of all this, let us make the estimate. And then we have to make the scope definition. This was the major work of the concept scoping. And then we end the first 1.1. So this is how the task, the composition is done for a major task, which was concept scoping. Defining a task network. Now, what major task we have decided with respect to the scope. Now we have to make the task set, and this task set will give you certain result, the work product. But these tasks, how they are related, they are sequenced, they are in parallel, they are concurrent. One product is required for another. So individual tasks and subtasks have interdependencies based on their sequence. So for example, if two people are given some tasks, so when more than one people is involved, development activities and tasks may be done in parallel. Therefore, the concurrent tasks which are going on together must be coordinated so that they complete when later tasks which are waiting for the work products produced by the previous tasks. A task network or the activity network. Please remember, the task network is also called as the activity network. This is a graphic representation of the task flow for a project. Task network, activity network. You used to see here, it's like a computer network or a people network, different kind of network. So here the network is of task. This is a graphic representation of task flow. Now this 1.3a, 1.3b, 1.3c, they are working in parallel. They are in parallel, but some are sequenced. So task network depicts major software engineering tasks. And you see here, this is a schematic task network for a concept development project. I told you about 5 projects. This is for the new technology or new business idea. Tasks that lie on the critical path. The longest path possible in this network is called the critical path. So tasks that lie on this critical path must be completed on schedule, else the schedule is definitely going to suffer. You have to do all this tasks at the first go. Others, they may not lie on the mainstream, they can be deferred. Project scheduling. Here we have the PERT, CPM, Gantt, all these. So these are generalized project scheduling tools. These are normally used in the project management. So these generalized project scheduling tools and techniques, this can be employed and applied to the software development projects also. So we have 2 project scheduling methods. Gantt is also there, we'll talk about that, but the project scheduling method, especially PERT, Program Evaluation and Review Technique, and the Critical Path Method, CPM. So here, first one, there are ways which we can differ. First one is the statistical method. The other one is the deterministic method. The first one is the estimation is not that much clear. The CPM, the estimation is quite clear. The durations are clear. Okay. And there are various differences here. We'll talk about the differences just now. But PERT, actually it came first. CPM is a refinement or a way to represent where we definitely want our critical path method or critical part to be seen. So PERT, Project Evaluation and Review Technique, is a statistical tool used in project management that was designed to analyze and represent the task involved in completing a given project. In this critical path, the CPM, a scheduled network analysis technique used to determine the amount of scheduling flexibility on various logical network paths in the project schedule network and to determine the minimum total project duration. So both these techniques, they are driven by certain inputs. So they are driven by information already developed in the earlier project planning activities. For example, if you assume all this has been done, that is the estimates of the effort already been done, a decomposition of the product function already been done, then along with this, the PERT and CPMs and the Gantts, they need certain input, and they're driven by this input, like the selection of the appropriate process model and the task set, because these task set will be put in the network or the timeline, and finally the decomposition of the task, if the major tasks are there, defining them in a task set. Program Evaluation and Review Technique, PERT. In this PERT, how do we do this? Let us take a very simple example. Here you see activity A, B, C, D, E. What are the activities preceding to these are given here. The completion days are given in PERT as optimistic, most likely, and pessimistic. For example, 5 is the optimistic for A activity to complete. Pessimistic says 7. Most likely is 6. So we don't have a single number. For every activity, there will be completion days, but there will be 3 options. So three way to think of it. That is why it is statistical. And what do we get? The final number will get from first row I'm taking 5 plus 4 into the most likely, then plus the pessimistic. So optimistic plus pessimistic plus 4 into the most likely divided by the 6 number. So this is the value which you are going to use, and you will do it for all the rows. So this is PERT. Now the example is, see, we have activity A, B, C, D, E. The duration are given as 3 days, 4, 5, 3, 4 days. And it depends on, or you can say the preceding activities are A, like this. So we'll start with start. There is nothing before A, so we'll start with A. And what is the duration? 3. So we'll make a round. That activity has to be written here. Outside you can write the day. Okay? A. Now go to the depends on and see all those activities which are dependent on A, or A is preceding these. So B and C. So from A, 2 arrows will come out. 1 for B, 1 for C. B and C we have written now. Same way. And 4 and 5 are the duration. So we just wrote those numbers near these round circles. Now B and C. Which activity are depending on B and C? D and E. From B there are 2 activities related. So from B, 2 arrows will come to B and E. But you also see that E is dependent on, or E is coming from C. So from C there will be 1 row to E. So here is the arrow to E. And what is the time of D? 3. What is the time of E? 4. So now that things are finished, so you just put a finish. This is a PERT chart, PERT network, PERT way. Critical path method, or CPM. This is almost like the PERT, There are certain differences. The difference is that here we talk about the critical path. This is deterministic, and in PERT, if you remember, that we used to give 3 values for this duration. For any activity to complete, there are 3 values. One will be optimistic, one will be pessimistic, one will be most likely. So what do we do? O plus 4m plus p divided by 6 we do, and then we find out the duration. That was done in PERT. Here, the notes, how we are going to write it. In the center, we'll write the activity name. Here, for example, A. A has duration 4, so we'll write 4 here. ES and EF, ES stands for early start. EF is standing for early finish. Let us take an example. Okay, now we'll start with A. There is no predecessor, there is no activity before A and C. So we'll start with a start, and there will be 2 arrows from start, one to A, one to C. This is 1 arrow, this is actually a flow. So A and C, so you're writing A and C in between, and what are the days? Duration 4 and 5, you're writing just above it. Like this, for A it is 4, for C it is 5. Now go to the predecessor and see all activities which are where A and C are predecessors. So A and C, B will come from A and C, and D will come from C. So from A and C there will be 2 arrows to B, and from C there will be 1 arrow to D. Okay. Now duration also we have written. So B is dependent on A and also C. D is dependent on C. The number is duration I am writing just above it. Okay. Now E is dependent on, or E has predecessor B and D. So B arrow and D arrow will go to where? To E, right? And the time will be 5. Finish, just put a finish, and it is coming from E and D. So from E, from D, the arrow will go to finish, end, right? Now what about these early start and early finish? Let us take an example. These both are starting with 0. When will B come? Because B is having arrow from A and C, but A duration is 4, C duration is 5. What is the maximum? 5. So we have early finish, you have to put 5 as B. Others are also there. Okay. Next is the critical path. See, we'll start with A, B, E. A, B and E. Now you just see the duration 4 plus 3 plus 5. What is the number? 12 weeks or days, you can say. Now the CD 15, 5 plus 10. CBE, how many? 5, 3, 5. It's going to be 13. CDE, this is 5, 10, 5, which is going to be 20. Now which one is the highest? 20 is the highest. So this is the critical path. CD is the critical path. PERT and CPM. PERT is program evaluation and review technique. CPM is critical path method. They are project scheduling techniques. They are coming under the project management. First thing is project management technique that shows the time taken by each component of a project, each task of a project, and the total time required for its completion. This is PERT. CPM is a step-by-step project management technique for process planning that defines the critical and non-critical tasks with the goal of preventing the time frame problems. In PERT, the PERT breaks the project into events and activities and lay down their proper sequence. That is the task which we have divided. What is the sequence? They are concurrent, they are parallel, they are in sequence, and relationship and duration in the form of a network. CPM ideally suited to projects consisting of numerous activities that interact in a complex manner. That is why we make a network in CPM. PERT is probabilistic model. The CPM is deterministic model. Because the duration is fixed, we know already in advance. In probabilistic, we'll take the optimistic, the pessimistic, and the most likely. And then, for example, let us take optimistic as 4, pessimistic as 7 days, and most likely is 6. So the final duration will be 4 plus 4 into 6 plus 7 divided by 6. That is why we are calling it as probabilistic model. This PERT is used in non-repetitive jobs like the planning and scheduling of programs. Normally it is used in R&D projects, research and development, where we don't know in advance. The deterministic model, where repetitive jobs like the residential construction, here we can use. The probabilistic model, results are calculated on the basis of events. In deterministic model, results calculated on the basis of activities. As I said, the PERT is related with activities of uncertain time. We don't know the upfront time. And deterministic related with activities of well-known, properly known time. Now this is all about this discussion today. We'll be taking the next discussion next part. Thank you so much.